It's something we may take for granted, but it's essential to our lives. Energy. It moves us, warms us, cools us, and keeps us connected.
Energy has given us all these miracles, but there are these unintended consequences.
A global climate emergency caused by the burning of carbon-based fuels.
In order for the world to get to net zero carbon, we need essentially a new revolution.
Charting the course to a clean energy future with Nobel Prize-winning scientist Steven Chu. It's the biggest energy transformation in more than a century. Solar panels, wind turbines, electric cars. But what's driving this enormous wave of change? It's our urgent need to break away from our long reliance on carbon-based fuels, on coal, oil, and natural gas. Because when we burn them, they emit huge amounts of carbon dioxide, a gas that traps heat in the atmosphere and is the principal cause of the warming of the planet. A dramatic change in our climate that's devastating people all over the world.
As we learn more and more, most of the climate news we're getting in the last 5 years has been bad news. It's a much more hair-trigger sensitive system than we thought. These are risks that society never had to face before. We essentially have to go to zero carbon emissions, certainly by the end of this century, if there's a hope of containing the worst of the risks of climate change. So that's a clue. So it must mean that the membrane's not wetting.
Steven Chu has spent a lifetime tackling some of science's toughest problems. For developing a way to trap atoms, he was a co-recipient of the Nobel Prize in Physics. And in 2009, he began a 4-year term as the U.S. Secretary of Energy.
There's also going to be a tremendous increase in the demand for accessible, affordable, clean energy.
A job in which he led the federal government's push to develop and implement cleaner energy technologies. And today, as a research scientist at Stanford University, Chu is still working on solutions to the world's energy problems. In the United States, more than half the electricity is still generated by burning coal or natural gas. Chu says that has to change.
First, let's talk about the easy stuff. We need to go as much to renewable energy in electricity generation as possible. So that's one issue.
The different kinds of renewables all capture energy from nature. A geothermal power plant draws heat energy from hot water and steam beneath the ground. A hydropower plant uses the force of moving water to rotate the turbines that drive the electrical generator. But wind and solar power are the fastest growing renewables because you can find wind and sunlight almost everywhere. Over the last decade, as the costs for these two technologies have dropped sharply, they've been adopted by more and more electric utility companies. By 2050, it's expected they'll provide some 40% of U.S. electricity. But wind and solar both have inherent limitations.
The shortcoming of wind and solar is the wind doesn't always blow, the sun doesn't always shine. And it's seasonal, depending on where you live. What do you do the rest of the time?
One solution is to make greater use of another carbon-free technology, nuclear power. For decades, it's been providing us with electricity by unlocking the energy inside atoms. This is an atom of uranium. When its nucleus is struck by a neutron, it splits apart and releases more neutrons, triggering a chain reaction that splits more and more atoms and generates a lot of heat. In a nuclear plant, that heat is used to turn water into steam that then drives turbines. But nuclear power is controversial because nuclear fuels, such as uranium, are radioactive, which means they emit radiation, streams of invisible particles, and waves of energy. And if the uranium fuel overheats, radiation can escape from the reactor and can cause severe damage to people's health.
When people think of nuclear, the first thing they think about is there going to be a radioactive leak.
We are now going into uncharted territory. We are thinking the unthinkable. Steam hydrogen explosion took place. 4 workers got injured, and all hell is breaking loose.
Since 1979, there have been major accidents at 3 nuclear plants. In 1986, at Chernobyl in Ukraine, so much radiation was released that within weeks, 30 people died. And people in the surrounding area experienced increased rates of thyroid cancer. Whether the radiation may have caused other illnesses is still being debated. The 2 other accidents were in 1979 at 3 Mile Island in Pennsylvania and in 2011 at Fukushima in Japan. At each of them, only small amounts of radiation were released, and among people who lived near those sites, health experts found no evidence of any illnesses caused by radiation. But despite these findings, many people remain fearful of nuclear power.
Nuclear is scarier to most people because it's more unknown. And when you think about this unknown thing getting inside you and causing cancers or things like that, that brings out a very primitive fear in people. But you have to compare that to the other devils we know.
Consider coal, for example, the world's most widely used source of electricity. The emissions from coal-fired plants cause respiratory diseases that each year claim more than 500,000 lives.
I think people are beginning to realize that you're not going to get to 100% renewables in the coming decades. And so you then have to make choices.
Some of the safety concerns about nuclear power could be overcome by a promising new technology, the Small Modular Reactor, or SMR. It's just a fraction of the size of a traditional reactor, yet it still generates enough electricity to power tens of thousands of homes. In Idaho, the first U.S. power plant to use SMRs is expected to come online in 2029. SMRs are designed to shut down automatically if there's trouble, so they can avoid meltdowns, the overheating of the uranium fuel that allows radiation to escape.
With small modular reactors, it could be made that there would be no chance of a meltdown that would cause contamination, which is the big fear.
Yet, even if we could eliminate nuclear accidents, we'd still have to grapple with another problem. Uranium fuel that's reached the end of its useful life is called spent fuel, but it's still radioactive. What should we do with it?
The United States still hasn't figured out what to do with our spent fuel, not because there aren't technical solutions, because we need political solutions as well. You need an acceptance of where you can ship it, how you can store it underground for tens of thousands to 1 million years. And that's the problem. So nuclear, I think, needs to be part of the solution, but it has these economic hurdles and public acceptance.
But there's another, less controversial way to ensure we have the electricity we need at the times when solar and wind fall short. Some of the electricity they generate can be stored in very big batteries and then released for us to use whenever we need it. Facilities that link together lots of batteries are now being built all over the United States. And in the developing world, in places that aren't connected to electrical power grids, even small batteries can provide big improvements.
So if you have solar, you can use batteries at night for reading, for studying, for anything you want. Small refrigerator that keeps perishables for a day or two, or that keeps medicine. You can bring clean water, water purification. You bring irrigation. You bring communication. Bring all of this stuff. Even a small amount of power will transform lives.
Batteries have another big role to play in our transition to a carbon-free future. They are the power source for most electric vehicles, or EVs, the technology that will enable us to move away from gasoline and diesel-powered vehicles, which emit lots of carbon dioxide. But today, most people around the world can't afford an EV. And one reason why is the cost of the batteries. One of their key components is a metal called lithium. All kinds of devices rely on lithium batteries, so the demand for it is huge. But the metal isn't easy to get. Most of it comes from mining, which is a costly process that also harms the environment.
And so you want to have access to different sources of lithium and make the extraction process much less polluting.
So scientists are looking at a new source, seawater. It contains thousands of times more lithium than there is on land. In South Korea and other places, they're working on ways to extract it.
This is much, much cleaner. And in principle, when it goes to scale, it can be much less expensive. And you can have enough lithium so we can support EVs. Maybe by 2035, maybe by 2040, you're going to see the majority of cars being electric vehicles. And that would be transformative. If one thinks about how much time we have to alter the course and transition to more renewable energy, if I could wave a magic wand, I would say, let's do it today, but that magic wand doesn't exist. It takes time to replace existing infrastructure. It takes time to replace personal habits. But the question is, can we have the energy without the carbon? And the answer is we can, and we must.